Hello, it's 10 o'clock on Thursday, so it's time for another Sprinkler Talk with me, Andy. Just a reminder, so I work for Project Fire. We're based in Staffordshire and we sell innovative and sustainable products into the automatic fire sprinkler industry. And what I want to talk to you about today is one of the products that we sell. It's one of the products that we invented. So yeah, it's very much our product, and it is here to provide sprinkler alterations without draining down. So last week, in episode 43, we spoke about drain downs and shutdowns, kind of the difference between the two. Obviously, that they mostly go hand in hand. So when you are draining the system down to perform alteration works, then you are also performing a shutdown. But with Livetap, that's slightly different because you can perform alterations without actually having a shutdown or a drain down. So you can actually do those alterations without affecting sprinkler coverage or sprinkler performance. So let's get into this. So if you remember, again, last week I went through some scenarios. So I looked at, why and where would you be looking to carry out some kind of sprinkler alterations? Why would you want to be doing that? So the first one I gave was scenario A, where it's a warehouse, so it's a kind of storage thing, and maybe you've invented a different product. You're now supplying a different product. Something's changed about the storage, kind of what you're packaging, how you're packaging it, and therefore the insurer has stepped in and said that some alterations to sprinkler works are required. So these need to be completed out of hours, presumably, draining down the whole system, refitting, pressure testing, etc. We'd say it's fine most of the time. We can do it over the weekend. It might be okay to shut the factory down for a week. But what if it's a bakery business? What if it's a 24/7 environment, and there's never a good time to do those works? So that's where Livetap can come in and help with that. Scenario B, I spoke about a hospital. Maybe they've already they've got flow switches already, but they didn't get zone checks to start with. So they'd want to retrofit zone check, and so we do sell a retrofit zone check option where you can drain down, you can drill some holes, and you can fit the zone check around the existing flow switch. But question I'm posing here is what about those areas that are being drained down? Presumably they've just drained down one zone at a time in order to fit the zone checks. Well, should those affected areas be used during the shutdown? They definitely will want to use them, being a hospital. Again, there's never sort of a good time to do those kind of works. So presumably they would put some other precautions in place. They might have some fire watch, for example, to kind of have a look out for fire whilst the works are carrying on. But again, with Livetap, we can actually add a zone check without draining down, and so the building can be in full use. Scenario C, I talked about an airport. I talked about kind of the difficulties that brings in terms of different ownerships and different permissions need to be done. Well, all of that's going to be simplified by the use of Livetap, because say things aren't needing to be shut down, everything's going to remain on, and therefore permissions are going to be a lot easier to reach. Paperwork is going to be simplified. There's still going to be paperwork, but not quite so much. The solution to all of this is Livetap. So it's an innovation for carrying out sprinkler modifications with no drain down. So this kind of principle of live tapping, or some people call it hot tapping, into existing pipe work is one that you can find in lots of different industries. Basically, whatever industry you've got that involves pipes, there's going to be some kind of tool to break into that pipe and fit fittings on, nice and quickly. Certainly in the plumbing industry, you can actually buy kits from B&Q or whatever, which, yeah, you can do this sort of thing. You can wrap it round an existing pipe, and you can do your own tapping into there to put another outlet in. So, you know, your washing machine, for example, or a hose connection, you can tap into that pipe and carry that out. So from that point of view, you know, Livetap is not innovation as far as the actual process is concerned, but there were some particular challenges to overcome with sprinkler pipework in particular. And Livetap is the only approved method for going into live sprinkler pipework. So what can you do with Livetap? Well, there's a few fittings here. So the no drain T allows you to actually add additional pipework and additional heads, all without draining down. So that will be useful in our airport scenario. A quick drain and a quick vent. So yeah, essentially they're the same thing. Valves are either pointing downwards or pointing upwards. So the drain comes in different sizes, and that can allow you to drain pipework. So that's like our best seller really is our quick drains, allowing you to get into pipework which has been trapped. So you've got trapped water in there. You need to drain it down in order to carry out some other works. So that drain valve allows you to do that. It could also be used for flushing connections as well. So if you're doing some kind of flushing requirements in the pipe work, and again you don't have enough flushing points, then again the quick drain can be used for that. A quick vent, say it's pointing upwards, so that's allowing you to vent pipe work, and that can be very useful because trapped air can be quite problematic as far as false alarms are concerned. So yeah, I attended to an airport in the UK, which was having issues where they were draining down, then refilling, and then about 24 hours later, there was an alarm going off, and yeah, we figured that was the trapped air kind of moving around in the pipework. Different changes in temperature and different pressures, you know, it all just suddenly that the air can move from one location to another, and that can trip off flow switches. So by putting a vent on there, we can vent the air off, and we didn't have that problem anymore. And then finally, the zone check live. So we can actually fit a zone check around an existing flow switch without draining down. So yeah, that's that for our hospital scenario B, wasn't it? They wanted to fit a zone check without draining down. The zone check live is the product for that. So here is a diagram showing you how the no drain T works. The no drain T is the most complicated one. So if I kind of talk through that a little bit, then that'll help you to understand all the other different fittings that we've got. So with the no drain T, again, traditionally what you would do is you would drain the pipework down, you drill a hole, and then you fit a mech T to it, and then you can add additional pipework, or you drain down, you cut the pipe, and you could put a T on there. With no drain T, what you do is you put the clamp on first, so you put the special mech T on first. You would then run all your new pipework and new sprinkler heads. You connect all that together, so you can see where it says new pipework there. So you can do all of that. You can air test that new pipework. You can backfill and pressure test that new pipework only. Then once you've done all that, then you can get the drill out of the toolbox. You connect it onto that valve there, and then you can advance the drill through the T, break through into the existing pipe, and wind it back again till you get to the valve. You close the valve, and then you can take the drill away. I've got a video coming up later which will show you that in action. But yeah, so there is a valve here, but you can see that valve is not in line with the flow. So that valve allows us to put the drill on and run the drill in and out, but then that valve is going to be closed. We could put a plug on the end of that valve and then we leave it alone. So it's there, it's closed forevermore, but our new pipe work is running off that T. So yeah, that valve is not in line with the flow. That valve is not going to affect sprinkler coverage going forward. There's like a cutaway view. So that's the moment at which the drill is going to penetrate through the existing pipe work to connect those two sides together. So you could do that dry. Your new pipe work could be dry, but it is best practice to fill that with water at a similar pressure, so that when you pierce through the pipe, you don't have water running from one side into the other, or vice versa. So yeah, you might have already sort of figured this out in your head, that we can't use the standard mech tees. The standard mech tees are on the right hand side and they're in red. So standard mech tees have a lip inside of them, and that will fit into the hole. So we drill a hole and we place that mech tee so that the lip goes inside the hole, and that's what kind of secures it in place. With Livetap, we can't do that because we're putting the fitting on first and then we're drilling the hole, so there is no hole for us to put that lip inside. So our fittings don't have that lip. Instead, we have these kind of teeth which grip onto the pipe. So again, we've demonstrated as part of the approval process that our fitting will not twist and bend and rotate, that it's going to stay put. Another common question we get asked about Livetap is, what about the swarf? What about little bits of metal filings? What about the kind of center of the drill, so where we're kind of drilling through with a kind of shell cutter, hole cutter? What about the bit in the middle? Because we don't want debris going down the pipe. So both of these are important questions. So we have a magnet inside of the cutter to collect the swarf, the metal filings, and also we capture that center bit of metal as well from the pipe. Again, that's down to the design of the drill with this retention wire, but also we 9 times out of 10 it comes away anyway, just because of the kind of friction of the drill kind of going through. But we always do get that coupon, we call it coupon, that the disc of metal to come away as well. Again, you'll see that in the video a little bit later on today. So again, the part of the approval process, we actually had to weigh the metal filings that we took off to kind of prove that we were capturing the majority of that metal. So I think we worked it out that we were capturing like 97% of the metal that's removed, which is actually a lot better than draining down and drilling a hole. Especially if you're drilling the hole on the top or the side, you are going to lose a lot more metal inside the pipe. So we're doing even better than the traditional modifications there. Training. So we run a training school here at Project Fire for use of the drill. Again, that was part of the approval process, that you would have to go through a training course before you would be sort of qualified to use the drill. So we run that from our base in Staffordshire, but there are other locations around the world that you can do that. That's the actual toolbox that you've got. Ignore the title there, pipe freezing. I did a copy and paste and I didn't change the title there. So that should be the toolkit. So that's actually what you're buying. So you're buying a toolkit, obviously a drill that can be reused many times, and then you buy the fittings, which once you put them on there, they're going to stay in place. So that's why I've got my title, pipe freezing. So just a quick note really is that I do sort of accept that there is an alternative to Livetap, and that is these kind of units here, which is like a big blanket which you wrap around the pipe, and then you use a solution that's going to freeze the pipe. I think CO2 is the most common one that you can use, or liquid CO2, to freeze up the pipe. So remember, I talked about dry systems all the way back when. where, you know, if the water in the pipe freezes, it's going to cause a blockage. Well, this is what we're doing. We are deliberately freezing the pipe to cause a blockage inside the pipe, and then we can carry out works on a smaller section. So yeah, freezing kits, you know, do have their place, so that they can be very useful. But yeah, one thing, I mean, I've never used one, but people that have, you know, the problem is that we're never quite sure that we've got a solid block. We've got an actual solid blockage within the pipe. So actually, you can use Livetap in conjunction with a freezing kit. So you can put a little vent on there, and then you can put a pressure gauge on that, and then you can run a little bit of water off, and you can just check that freeze kit is completely in place. And then you can drain down that smaller area whilst you've got that blockage in place. So freezing kits, yep, do have their place. Horses for courses, but yeah, Livetap does have its unique advantages, and also say Livetap can be used in conjunction with the freezing kit to make sure that blockage is secure. As I mentioned, so Livetap is fully approved, so we've got LPCB, FM, UL and VDS approval on the system and our fittings. So yeah, remember last time, episode 43, I looked at some problems with traditional modifications. So the benefits of Livetap are like the opposite of those. So we definitely no drain downs, no associated fees to do with isolating the zone valves, etc. We're saving lots of water, again depending on the size of the installation, the size of the zone, we're going to save even more. No loss of sprinkler protection during works. I mean, that's the main one. That's the main advantage, really. It's cost effective because it's quicker. We're not activating fire pumps. We're not generating any alarms. We can work during normal working hours. We don't have that kind of time pressure to get the works completed for an actual deadline. You know, it doesn't matter quite so much with Livetap as it would do for like a shopping centre where you've kind of got there. You're working through the night, and it's got to be working so the customers can come back in. Yeah, no more backfilling. So yeah, those are some of the advantages that come with Livetap. All right, so I'm going to now show you a little video of this coming together. I'm going to play. Come on, video. There we go. So you can see I've speeded up this part of the video. Adrian's not that quick. So he's just preparing the drill. So you've got the drill out the toolbox. Obviously, depending on what fitting you want to fit, you're going to use different components that are going to go into the drill. So yeah, we're kind of putting those components together in order to create the setup that we need for this particular fitting. So yeah, we are putting the shaft in there, and then the shell cutter on the end. This is quite a small one that we're using for demonstration purposes. So we're fitting that shell cutter, and then we're going to put the pilot drill in as well. So that pilot drill comes in first, just showing you. You just saw it very briefly there, the magnet and the retention wire. You'll see when the drill's finished, you'll see the metal filings all sticking to the drill at the end. So there we are, we're all ready to go. You can see that black section, that kind of black sort of hexagon section, that's what we're going to screw on to the end of our fitting. So here we've got a piece of pressurized pipe. You can see the pressure gauge there running, 14 bar, 15 bar. So we're going to screw that black section there onto the quick drain. This is a quick drain we're using. So we're screwing that on, and that's got a rubber seal. So once that's on there tight, we create like a watertight seal with those two components together. One thing that, again, sort of unique challenges, double checking things. We're using a bicycle pump just to check that watertight seal between the Livetap drill and the fitting. Because, yeah, in the past we have had that sort of kinking, the rubber seal kinking, and then, you don't get a watertight seal. So the bicycle pump just checks that. This sort of gauge that we're using, this ruler, it tells you the position of the drill relative to the valve. So again, we want to line that up, and then we can open that drain valve there, that ball valve, and then we can run the drill, so running the head through the ball valve until it touches the red pipe. So again, the ruler will tell us that, yeah, we are just touching the pipe. Then we can get the handle onto the drill, and then we can actually do the drilling process. So this is a manual process, so we take it nice and steady. So we've got one hand which is rotating the drill head around, and the other head is just advancing the drill forward, and so those two actions together are kind of the cutting action. So again, what we're going to do now is we're going to put the bicycle pump back on again, and we are now checking the seal between all of the components. So we're checking that the fitting now. So we're checking to make sure that fitting has been, again, there's a rubber seal around the mech T. Again, we're checking that is all in place. Just that little bicycle pump showing that everything is ready. So now if you watch the pressure gauge, in a minute we're going to see that pressure drop. So we've only got a small amount of pipe here. So when the pilot drill pierces through the pipe, then we are going to get a significant pressure drop because, proportionally, percentage terms, there's quite a lot of difference in the volumes. There it goes. But obviously, normally in a much larger sprinkler system, you wouldn't expect a significant pressure drop really, because proportionally the difference between that little bit of water moving into the valve is going to be very, very small. So the pilot drill's gone through, and we just saw Adrian advance the drill, so the shell cutter is now going through the pipe. So again, more drilling by rotating the drill head and then advancing the drill forward, and so that obviously takes a few minutes to go through. Drilling it with when you drain down the pipes, you can use it as a standard drill. Obviously, that's a lot quicker for the actual drilling process. But with Livetap, you don't have to wait for the water to be drained out. Sorry. So there we go. We've gone all the way through. So that shell cut has gone all the way through, which means that the drill is complete. So now what we need to do is back the drill all the way back out again. So we're backing the drill off through the ball valve. And again, we're using our ruler, our kind of gauge, to make sure that drill is clear of the valve. Again, because we don't want to sort of squash the drill bit in the valve. That's going to cause us problems. So yeah, we're going to back it all the way off, and then we're going to use our gauge. Here we go. Using the gauge to make sure that the cutter head is clear of the ball valve. And we can close that off. And now we can remove the drill from the valve. So there'll just be a tiny amount of water that's kind of trapped within that black section there. So we're just going to get a cloth, I think. But say it's a very small amount of water that's captured in there. There we go. And then we're just going to see the drill head in a second now. So it's going to pop up through the top of there, and then we can see it in a bit more detail. There we go. So we can see the metal filings that have all stuck to the drill because of that magnet. And we can just about see the little disc. You might not be able to see it But yeah, I can see it's there, the kind of center of that shell cutter. There we go, and that is Livetap. To say Livetap can be used a whole variety of different situations. It's a product that we've been selling for quite a number of years. Most of the kind of major sprinkler installers in the UK, I've got engineers that are trained in using Livetap. They have toolkits on their van. So yeah, would encourage you to kind of ask when next doing a sprinkler alteration, to ask and say, can we use Livetap for this? Okay, so that's it for today's presentation. Next week, we're going to be looking at pipe supports and pipe finishes. So we're looking at, there's actually quite a lot of detail in the standards about what supports you can use, where they should be located, what needs supports and what doesn't. And then the pipe finishes, we're going to be looking at painting, galvanized, and sort of looking at how that pipe work can be finished off. So yeah, I hope you can join me for next week, which will be episode 45, won't it? So yeah, we're going to be looking at pipe supports and finishes next week. Okay, thanks a lot for tuning in. Thanks for listening. Bye-bye.